What's up, everyone? Welcome to Tutor Terrific. I am so glad to be here on my first live stream. I don't know who's going to show up. I had issues. I use StreamYard, as you can tell. Oh, got to get used to that right up there. If this goes well, I'm going to definitely look at purchasing something from them. This is their free version right now. I'll test it out. But welcome, everybody. I had some issues posting these live streams on the channel so that you can see them. It wasn't showing up in the videos feed. I don't know why when I scheduled this thing, but I made subsections under that so that you can see upcoming and past live streams and when I'm live too. So those will show up soon. But hey, this is my first time doing this, and I am super stoked that YouTube makes this possible. I'm sure you've heard that before. But I'm new to the game, but I want to help people. I want to help people all over the world. I want to help people no matter where they are with what they need help with when it comes to educational endeavors. So let me know either in the chat over there or in using that email address as I put in the chat. Let me know what you need help with, whether it's something content related or a specific problem. You're just having trouble with a concept, I'm here to help. And I have something planned just in case no one is game right now, and that's just fine. I've got a lesson on partial fraction decomposition, which people seem to think is quite hard, and that's just fine. So we're going to do that until people show up. And we'll see if people show up. It'd be awesome if they did. But yeah, if I get a lot of people, and when I get a lot of people, I will certainly, any donations, any things you do like super chats or the little thanks heart are awesome. I will definitely be prioritizing the super chats that come in and the questions that people have if they use super chats. So we'll see. Lots of things to test out here, including StreamYard itself. Very, very stoked for this whole thing. So without further ado, let me get my screen shared here, and let's look at what I'm doing on this particular thing here called my screen. Just let me figure out, got to share that screen. Figuring out how to share my screen. I thought this was it. Ah, yes. There it is. We're going to share this one over here. All right. So you guys should be seeing that now. Partial fraction decomposition. By the way, I have discovered a long time ago, one of my students showed me this thing called Miro. And yes, of course, we've had Zoom for, 2-3 years now. And it's been really annoying. And their whiteboards aren't very great. But my friend showed me this thing called Miro, and it blows Zoom's whiteboards, even their new whiteboard feature, out of the water. This is a game changer, and it's free. And you can share your whiteboard universe space, which I will show you here. I have this lesson planned for partial fraction decomposition, but I'm not even, I can go anywhere I want, and I can add graphics, I can add graphs, I can add images, I can add YouTube videos, I can actually embed videos into this universe whiteboard space, and multiple people can be live going on here and working on it, which is great at the same time. And you can, if you have multiple people in here, you can have someone up at the top here. You'll see all their icons, and you can click on their icon and go right to where they are if you're lost and follow them around while they're writing. It's really cool. And it doesn't seem to limit how many people you share your board with, they call it. This is my board called YouTube Lives, but I have another board that fits every single one of my tutoring students. Every single one, they get their own little section of the board, and they just know to go right to it when they start my private students sessions. So yeah, let's do this. Partial fraction decomposition. Okay, partial fraction decomposition is, you could consider, when you're getting new to this topic, the opposite of combining fractions with unlike denominators, or like denominators, but combining fractions with rational expressions in them. So not just numerical fractions, which are easier, but algebraic expressions in the numerator and or denominator like we have here. So understanding this, guys, is going to require you to have some algebra background. Certainly, if you're not using Common Core style math, you should be through Algebra 1 for sure, definitely. But having Algebra 2 under your belt is a plus. Being in pre-calculus is where you would learn something like this. Maybe some of your schools call that trigonometry. If you aren't in, if you are in a Common Core setting, I would want you to be in Math 3 before you start to learn this. But hey, if you think you can follow along and you've combined fractions before, you can probably keep up. But let me tell you, it's the opposite of what I'm about to do. But I want to give you an example just to get you in the zone here. So if we have 2 over 5 plus x plus 6y over 6 minus x, we have different denominators. And so we have to combine them the proper way. We have to combine them using a least common denominator. We can use a other common denominator, but the least common denominator will assure us that we don't have to do any simplification later. So now we need to find the LCD, okay? That's the first step. So when you have rational expressions in your denominator like this, the least common denominator will have one copy of every unique factor and one copy of every common factor. Again, let me say that. One copy of everything unique, one copy of everything common, okay? So there's lots of different ways that teachers teach that, but this is how I do it. Let's look at the denominators here. We've got 5 plus x and 6 minus x. You might say, well, they both have an x, but x is not a factor. 5 plus x is a factor, and 6 minus x is a factor, and that's all I care about are the factors. So these are unique. They are not identical. And so the least common denominator will have one copy of each in its product, okay? Least common denominator is a product of factors, okay? So this right here is the least common denominator, okay? And you can choose to multiply that through with the double rainbow method or the box method, whichever you like better. You would get 30 minus 5x plus 6x, which is just x, minus x squared. And I'm a stickler for writing things in standard form. So you'd have, you'd switch the order here and put the negative x squared first, the next lowest power of x in the middle, and then the constant term at the end, plus 30. And then you'd have your least common denominator all multiplied out, or you could just leave it factored like we have up here. It's up to you. I like it. It looks a little cleaner like this. So that's my preference. So what we're doing is we are going to multiply each of these fractions by what their denominators were missing from the LCD, okay? That's what we're going to do right now. So this first one, 2 over 5 plus x, it was missing the 6 minus x from the LCD. It didn't have it downstairs. So I need to multiply using the denominator numerator same quantity rule, okay? I'll explain what that is. I can multiply a fraction by any non-zero quantity as long as I multiply the numerator and denominator by the same non-zero quantity. I will get a fraction that has the same value. That's really helpful because I can change what the fraction looks like even without changing its value, doing it this way. 0 doesn't count. You cannot do this with 0 at all, at all, at all. When you multiply by 0 over 0, first you're multiplying by something that's indeterminate, doesn't have a determined value. And you're getting rid of a lot of information when you multiply something by 0 because the product is 0 and there's nothing left. So we don't want to do that. What we do want to do this. We want to multiply by the factor, again, from the LCD that was not present, or all of them that were not present in your fraction's denominator. In that case, it would just be 6 minus x. So 2 over 5 plus x turns into this. Now we'll do the multiplication in a minute, but next what we have to do is we have to look at the next fraction, 6y over 6 minus x, and say, what's missing from here? Well, I'll show you. 6y over 6 minus x. I care about the denominator, guys, 6 minus x downstairs. That's missing from the LCD, the 5 plus x. And so I need to multiply the top and bottom by 5 plus x. Okay. Don't start canceling stuff. If I cancel like this and like this, because I have my cancel trigger, my cancel finger on the trigger, that's not going to be good. So don't do that. Okay. You need to multiply. Okay. Don't put anything. You need to multiply. So on top, we're going to distribute the 2 in the first fraction. That's 12 minus 2x. And the other fraction, that'll be 6y times 5. That's 30y plus 6yx, or 6xy if you like doing things in alphabetical order like me. And I'm going to use that nice multiplied out version of the denominator. Negative x squared plus x plus 30. It's not just any denominator, it's the least common denominator. And so here we have now 2 fractions that have the same denominator, which means we can add them. How do we add fractions with the same denominator? Well, we make really one fraction with that like denominator, equal denominator, I should say. So one copy of that negative x squared plus x plus 30 for one fraction now. Just one fraction. On top, we're going to add these two expressions. Now we add using the rules of like terms. Terms that are like can be added. What do they have to have? They have to have the same variables to the same exponents. If they don't, you can't add them any more than you could just write them next to each other with a plus or a minus sign between them. So let's look here. 12 minus 2x, 30y, 6xy. None of these are like. That's okay. It doesn't mean anything's wrong. It just means you have to write them with a plus or a minus sign between all of them. You just end up with this right here. Fortunately, that's really weird, complicated. But most of the reason why is because I had a variable up top in the beginning. So that's combining fractions with unlike denominators. Okay, we're going to do the opposite of that. We're going to start with something, thankfully not something this crazy over here, but we're going to start with the end and go back to the beginning. Okay. Step 1, when we do this, okay, there's a specific step order. When you have your fraction, if it is improper, you must divide. So you must divide if improper, okay? You must divide if improper. So if you have a fraction with a higher degree, and by the way, I'm rolling into examples that have one type of variable in them, like x or y, and it's the only one. But if it's improper, meaning the upper degree is higher in the numerator than the lower degree, that means the higher power of x is on top, then you have to use long division, or if you can, based on the format, synthetic division, to get a quotient and a remainder. And that remainder, as you know from long division, you're going to write that remainder over the divisor, over the denominator. That will be proper, and then you can move on, okay? So if it is improper, write remainder, I'll just call it r of x because it's a polynomial itself. Write r of x over the divisor, I will call d of x, and continue to step 2. Okay. Now, step 2. What is step 2? Step 2 is to set up your denominator properly. You need to factor the denominator fully. Fully factor denominator. You need to look at what your simplest factors look like. All right, denom for denominator for short. Okay, you want factors that look like this. Okay, one of these two types. Linear factors. Those we're going to say have the form px plus q. So x is our variable. P and q are numerals, coefficients. And it can be raised to any power. Obviously, the more complex it is, the higher the power of m is. Or they could be quadratic. A little bit more involved if they're quadratic. But those could look like this. ax squared plus bx plus c. Notice how x is squared in these. And that could be raised to any power. We'll just say a different one than the other one, to the n. Now, these are irreducible, these quadratic ones. I'll explain what that word means. Irreducible. When something's irreducible over the reals or over the real number set R, that means I can't factor it, okay, into nice rational numbers, okay, or even irrational numbers. This thing has complex solutions if it has any. So that's what we want. We want an irreducible over the reals, no factoring possible. That's the main point, okay? If you do have a quadratic factor that you can factor further, do it and turn it into a linear factor. Okay. Now, step 3 is really depending on what type of factors you have. For linear factors of that form, px plus q to the m, we have to set up partial fractions, okay? On top, the numerator will have just a number. Each numerator will have a unique number. Well, they could be the same. We're just going to pretend like they're not. Give them each a different subscript. And a1, a2, all the way through up to the power itself, m, that the linear factor is raised to. On bottom, we will have the original linear factor, but each time we write it to one higher power. Wow, pq plus q, come on. Hello. Px plus q. Now it'll be written to the squared power. It's the second term. We go all the way, px plus q cubed, px plus q to the fourth, all the way up to whatever m is, px plus q to the m. Okay, sometimes you're really, gosh, all these are this long. No, they're not. They're not all this long. Do not worry. Okay, next, for the quadratic factors, the setup's a little different. On top will actually be linear. b1x plus c1 for the first one. And on bottom, you'll have that quadratic factor raised only to the first power. Remember, this is irreducible. Okay. The next one will be a whole another set of coefficients with that x, b2x plus c2. Just the little 2 subscripts mean it's different than the other ones in the previous fraction. And that will be raised, that'll be divided by a denominator that is raised to the second power. So we're going to continue doing this all the way up until we have m fractions matching the power. Oops, I'm so sorry. That should be an n. It could be different than the other one. So we're going to go all the way to n, whatever it is. bnx plus cn all over ax squared plus bx plus c to the, can you guess it? N power. Okay, again, looks super complicated, but what we're going to do next will hopefully make sense of this, okay? Getting these coefficients on top, or these numerals on top, is the work that you must do. And so we need to do that. So here's our first example, okay? X plus 7 over x squared minus x plus 6. Now, when we do this, we have to start by making sure we have a proper fraction when it comes to degree. And we do here. The top degree is smaller than the bottom degree. How do I know degree? It's the largest power of x in the polynomial that you see. So the numerator polynomial is x to the first power. The denominator polynomial, the degree is 2. The highest power of x is 2. So the denominator has a higher degree. So it is a proper fraction. So we're going to skip right to factoring the denominator. Okay, look here. This is a trinomial, a quadratic one. And so we look and see that the first coefficient is 1. So we've got a simple method for factoring this. What two numbers multiply to -6, the constant term, and also add to -1, the coefficient of the middle term? And the answer, I'll give you a second to think about it. Six is 1 times 6, or 2 times 3. -6, we've got to have one of those be negative. The combination that works such that they also add to -1 would be -3 and +2. Like that. And so what we do, thankfully get to skip all of the intermediary group factoring steps from the AC method. We get to skip all that. And we get to write two parentheses already multiplied together. Each start with the x. And then you add in these found numbers from your little exercise over there. Okay, hopefully you've all seen this before. If you're not familiar with that, you're going to kind of be lost, okay? So maybe you're not done with Algebra 1, or you aren't done with Math 1 yet. Ouch, you've got to know your factoring. Okay, that's okay. I shouldn't say ouch. I should just say this is a little bit beyond what you're able to understand, most likely. But that's factoring, and I've fully factored the denominator. I have beautiful factors that are linear, okay? Now, but they're each raised to the first power, okay? So I must have one partial fraction for each one of these, okay? The first one will just be a on top over x minus 3. It wasn't raised to a higher power, so I don't have to add more fractions and more letters, more versions of a on top. I'm done with that one. But I've got another fraction because I've got another linear factor on bottom, x minus 2 to the first power. So I'm going to have to add another fraction that's got x plus, sorry, I keep saying minus 2. It's plus 2 on bottom. On top, I'm going to use a different letter for my numbering scheme because I'm starting over with another linear, factor. Okay, and as I said before, we're done creating these partial fractions. We have to find a and b. Okay, that's the goal right now, is to find a and b. So here's what we're going to do. We are going to multiply by the denominator of the original fraction. In factored form might be a little easier. Imagine doing that from here to here. Imagine multiplying both sides by x minus 3 times x plus 2. What's going to happen? Well, I'll tell you what's going to happen. What's going to happen is that the entire fraction, the entire equation is going to lose all of its denominators. It's very easy to see that that happens on the left side because you're multiplying something that's already divided by x minus 3 times x plus 2 by x minus 3 times x plus 2. So this is going to delete this, and we're just going to get x plus 7 over here, and that's what we want. On the other side, if we distribute this in, we can see that part of it's going to cancel. So a times x minus 3 times x plus 2 divided by x minus 3, the x minus 3 is going to cancel. And you're going to be left with a times x plus 2 on top. Okay. The other one, if you multiply in x minus 3 times x plus 2, the x plus 2 is going to cancel, which is just leaving you with b x minus 3. Okay. And that's a lot of work. We've got more to do. We've got to do the following. We have to distribute these a's and b's to these linear factors that now multiply by them. Then we're going to do a little investigative work with this equation. Because we've only got one equation. We've got two unknowns to solve for. So watch this. ax plus 2a. Ooh, getting ahead of myself there. ax plus 2a plus bx minus 3b. Like so. And what we're going to do now is we're going to combine like terms, meaning terms with the same variables. Okay, there are two terms with an x in them on the right. And so we are going to combine them like this. And factor out that x. So there's an ax and a bx. That's a plus b times x. Then we have plus 2a minus 3b, not really common at all. We'll just stack those in the end. Those are going to make up a constant. Okay, they're just numbers. Now, if I'm saying this is equal to x plus 7, I'm actually implying quite a bit. Okay, what's the coefficient of the x term on the left? It's 1. This implies, because I have only one x term on the right side, that a plus b has to equal 1. This is the first equation that I've created where I can actually solve for a and b. But that's not enough because I need 2, and I only have 1. Okay? So what we need to do now is we need to set the other portion of this to 7. Okay? 2a minus 3b equals 7. Okay, now I have the proper number of equations to get a and b. 2. So each time you do a partial fraction decomposition, the more complicated what you started with is, the more equations you're going to have, but you're going to be able to solve them as a system like this. Sometimes you get some very easily. In this case, we've got to work for it. I've got this beautiful system of equations here that's set up just perfectly for elimination as my means of solving. And so I'm going to go ahead and multiply the top equation by 3, which will give me, and I'll write it below, 3a plus 3b equals 3, like this. And I add these two equations. The b terms cancel, and I get 5a equals 10. 2a plus 3a is 5a. 7 plus 3 is 10. If we divide 5, you can see a equals 2. We found one of those numerators. Awesome. Finding the other one is a cinch. You back substitute. Take that value you got for a and plug it into any of the equations you have here. Top one is the easiest. Imagine it without being multiplied by 3. You've got a plus b equals 1. Well, now you can substitute in what a is. It's 2 plus b equals 1. So if I subtract 2, then I'll get b. B has to equal -1, okay? So I found a and b. Now you're not done. What you got to do is go back up here, and you got to write the fractions, those partial fractions with their found numerators. So a was 2, and b was -1. So you could write that instead of plus a -1, you could write -1 over x plus 2. Now, what you want to do, obviously, is you want to make sure that this is right, okay? How can you make sure this is right? Well, you can combine the fractions, do the exact reverse using older maths that you learned years ago, okay? These denominators aren't like, so I have to multiply by the LCD. We've worked with the LCD enough in the example that you know the LCD is just the combination of these two factors together. So the first fraction needs the x plus 2 because it didn't have it in the LCD. And the other one needs the x minus 3 multiplied by it because it didn't have it in the LCD. I mean, it didn't show it in its denominator. That part of the LCD was missing. So when you multiply through, of course, the denominator is x minus 3 times x plus 2. Just for time's sake, I'm going to leave it unfactored. Factored, not multiplied out. The top is what I care about. 2 into x plus 2, that's 2x plus 4. Now be careful here. This is a minus sign. I have to distribute it to all the terms that follow it. So 1 times x times a negative is minus x. 1 times negative 3 times the negative is plus 3. Now here, in this case, we actually do have some like terms. 2x minus x is x. 4 plus 3 is 7. Multiplying the bottom, you get x squared minus x minus 6, which is what you started with. So it checks out that this right here, 2 over x minus 3 plus minus 1 over x plus 2 is correct. Now you're thinking, man, this is crazy. This is so hard. This is so much work. I could just guess and figure it out. No, you can't. Yes, I can. I can factor it and then just split them up and then guess what A and B are. No, you can't. These are not intuitive numbers. It's because of the work required to get to them that you can't just intuitively just guess what they are. You can't. Okay? So that is not a good strategy. A good strategy is this strategy, and it's up to you to get used to it so that you're not lost. Okay? But it takes practice. So we're going to do another one. Whoa, look at this guy. This guy is a little bit more complicated. Oh my goodness. So if this guy is this complicated, is it a totally different method than before? Hi, I see you. Thanks for joining. Ask for any help you need on anything. I'll stop what I'm doing and I'll help you. Or bring your friends in. I'm here till 11 Pacific Standard Time. So what I want to do now is step 1, which again is look here. Is the degree of the numerator correct? Is it smaller than the denominator? Yes. I've got degree 2 on top with this 2 here, or degree 3 on bottom. And that means it's a proper fraction again. So I don't have to do any long division, which would really, that would be a pain here. Okay. So what we're going to do is we're going to factor the denominator, okay? We'll just keep writing the numerator. Don't need to change it. The bottom, we can factor. Start by looking at all the terms. Is there something common to every term? We could pull out the greatest common factor. Okay, and that's x. Every term has at least an x in it, so that means that x is the greatest common factor. I'll factor that out first. I have x squared plus 2x plus 1 left. Okay. Is x squared plus 2x plus 1 irreducible? No, it is reducible, okay? You might not see it, but this is a perfect square. And now there's ways to tell. For example, is the coefficient in the middle double the final coefficient squared? Yes, that's one way to do it, but you don't have to do it that way. You could do this, the x method. Can I think of two numbers that multiply to 1 and add to positive 2? Yes, of course. Can you? If you can, good for you. It's 1 and 1. Okay? Good for you. All right, so that means I can factor the denominator further, which is good because quadratic factors are more work. The algebra in this algorithm above is more complicated, but doable, just more work. Okay, so I've got that x there, and now instead of writing just x squared plus 2x plus 1, I'm going to write two parentheses. Each has an x, and each has a plus 1 from our little investigation there. Okay, so really what I have are three linear factors, but not really. They're the same. Like I said, it was a perfect square. So I shouldn't write it like this. I should write it like this. Okay, so what I have is a repeated linear factor, whereas before in the previous example, I had distinct linear factors. Not a problem. Not a problem at all. Okay, so here's what I'm going to do. I'm going to set this up. Now I can think of x as x plus 0, okay? So I'm going to have an a over that x plus 0, and I don't need any more copies because it was just to the first power. Then this next one, I have a linear factor, but I have the second power of it. So I'm going to have a b1, or you could write c, b and c. It actually works. It's a little easier if you do it that way. B over x plus 1, and then c over x plus 1 squared. Why? Because it was squared here. I have to repeatedly write these factors as denominators, raising the power until I get to the power of the fully factored denominator, original. And so I have this here. It's now ready to go through and multiply everything by the least common denominator. Well, sorry, the denominator as it's factored. So I'm going to multiply everything by x times x plus 1 squared on the left and the right. This is going to cancel. Over here, only parts of it are going to cancel. So the left side, 5x squared plus 20x plus 6, set in stone. The other side, the first fraction, a over x, the x is going to cancel, leaving us with just a times everything it already didn't have. You saw that pattern already. And then b, one power of x plus 1 is going to cancel, so that b will be multiplied by x times the other x plus 1. We'll distribute that. Then c, the x plus 1 squared will cancel, so we just multiply that by x. Okay, a little more work here. Now I have to do some foiling, and I have to do some multiplication, so I can start to group stuff differently in a way that's helpful, like I did in the previous problem. So FOIL here and multiply in by a. That's ax squared plus 2ax plus a for 1 squared. Then bx times x, bx squared plus bx, okay? And then cx. Okay, like I said before, group all like powers of x. Okay, don't do anything to the left side yet. So, and factor out the x squared from them. So I've got two terms with an x squared, a and b. So that's going to make a plus b x squared after I factor the x squared out. Then we've got first power of x terms. I've got a 2a plus b plus c x. All right, cool. And I only have one term without any x's. It's just a. Oh, that's nice. Okay, you'll see how awesome this is. But at first you're like, oh my gosh, I have 3 different letters to solve for. I'm going to have 3 variables. Oh, no. Yes, you are. But that's okay. Trust me, this isn't nearly as bad as it looks. And you're not going to use elimination to solve it. Okay. So, why am I doing this again? If the left side equals the right side, we could set coefficients equal to each other, just like in the previous problem. Okay. What we're going to do at the front is we're going to set 5 equal to a plus b. 5x squared has to equal a plus bx squared because the power of x. The next one's the hard one. 20 equals 2a plus b plus c. Oh dear, 3 variables in that equation. The next one is the simple one. The constant terms have to be set equal. 6 equals a. Oh my gosh, I already know what a is. A is 6. Oh, that's so nice. Okay. So what would I do next? If I know that a is 6, what would I do next? I would find b, because the first equation has just a plus b. So I will write 5 equals 6 plus b, plugging in a. And I don't know if you can see that, but 6 plus b equals something less than 6, 5. That means b has to be -1. Awesome. Okay. And then this isn't so bad now. To find c, we just plug a and b into the second equation. 20 equals 2 times 6 plus -1 plus c. So 12 minus 1, that's 11. 20 equals 11 plus c. I think you can see right now, just with mental math, that c equals 9. Okay. All right, we know what a, b, and c are. So we come back to our partial fraction decomposition. And I just realized I scared away that one person. Yikes. It's kind of awkward when you're that one person watching someone else's live stream on YouTube. So if you do that again, sir, I will make sure not to say, hey, buddy, I see ya. Hey, ask questions. I won't do that to you. That's kind of freaky. All right, so come back up here. Our partial fraction decomposition is going to be the following. It is going to be 6 over x. And then we've got a -1 for b, so -1 over x plus 1. And then plus c, which is 9 over x plus 1 squared. Whoa, that parentheses is out of control. What is going on there? There we go. I am going to leave it as an exercise to the listener or the reader to check this, but I can assure you it will be right. And it's not going to be nearly as easy as the previous one to combine those, but you can do it. All right. There is my lesson on partial fraction decomposition. And it's been about 44 minutes. So at this point, I would start to wrap up if I'm not getting any questions anymore. Just do a last kind of shout out for any questions we have. And then I would answer those. Of course, again, giving preference to the people paying, the super chatters. So I'm hoping this goes big. I'm hoping people see the use in it. I'm hoping to be able to do this a lot and get a lot of good usage out of it for people so they can get their questions answered, not just in math, but in sciences, writing. I'm here to help all around. And I'm not going to sit here and say I have all the answers, because I don't. I might be wrong at times, and you're free to correct. Just be respectful so I don't have to ban you or remove you from the chat because you're being a troll or you're being a jerk or you're being a degenerate. Don't do any of that stuff. be kind, be professional, and let's get some stuff answered. That's why I'm here. This is going to be I think a really good thing for YouTube if more and more people start doing this. But I'm going to start it. All right. And I'll just be facetious. I could be literally the 1500th person to actually do this. We'll see. I just haven't come across it, and I'm probably the only one doing it with Miro. So we'll see about that. But like I said, guys, I would wrap up at this point if I don't have anybody asking any more questions. And it's been a pleasure for all of you who are going to see this post, and for you, one person who I scared off. I love you. I don't hate you. It's just awkward. I get it. But yeah, guys, I'm here to help. I love helping. If I could support my family doing this, I'm certainly going to try. And yeah, I love teaching. So teach more people. We'll see what happens. All right, guys. Thank you so much for watching. This has been Falconator signing out.